Hey everybody, this is Mr. Walsh, and today we're going to be talking about the mole. And when we talk about the mole, we mean the unit of measure of chemistry, and not the furry animal, or not that little thing that you have on your body. So a mole is just a number. Okay, so if we think about what a quantity of things, a word that represents a quantity of things, we have a dozen, which is 12. Okay, some of you may not know. A ream is 500. If you have a ream of paper, it's 500. A gross, typically they sell pencils in grosses. I know that sounds weird, but they do that, and that's 144. What it is it's a dozen dozens. Okay, other things like a pair, couple. Okay, all of those things are things that we know the number of. So a mole is the same sort of thing as a dozen. It's a word that represents 602 sextillion things. Okay, it's not just this furry animal. It's not this mark on your body. Okay, 602 sextillion. So this is what that number looks like written out. This is what it is spelled out, and this is the way you normally would see that. And so here's the thing: atoms are very small. So if we think of grains of sand, okay, right here, okay, grains of sand. If we had a mole of grains of sand, it would cover the whole state of California. Let's see if I can get a good picture of California here. Okay, the whole state of California then would be covered 10 feet deep in sand. Okay, that would be if there was a mole of sand. Okay, if we had a mole of pennies, we would be able to spend $1 million a minute for the rest of our lives. And when I say we, I mean everybody. The whole earth could spend $1 million a minute for the rest of our lives and still have more than half of their pennies left. Okay, so I mean, the point is that a mole is a huge number, but because atoms are very small, we use a large number to represent them. So I have a full bottle of Coke Zero here. Of course, it's Coke Zero because that's my jam. Okay, and so with this bottle of Coke Zero, there are let's see, if we were looking at moles of water, there's going to be something like 40 moles of water in this thing. Okay, so remember, 1 mole of sand covers the whole state of California 10 feet deep, and this bottle of soda has 40 moles in it. So imagine if this was 400 feet deep with sand, it would be wild. Okay. So the idea is that atoms and molecules are super small, so we need a large number to represent. So the periodic table shows the mass of 1 mole of every atom. So if we look, that molar mass, that mass on the periodic table, if we look at carbon, okay, carbon's mass is 12.011. And so that's 12.011 grams for every mole. Okay, so that means that 1 mole is 12 grams. And so every element has a different mass per mole. So if we think about a real life example, okay, baseballs, okay, and tennis balls, they're both balls, but they have a different mass because they're different things. So a mole of a dozen baseballs weighs 8 kilograms, but a dozen tennis balls is less. Okay, so the same thing with this. A mole of carbon weighs 12, but a mole of lithium has a molar mass of 6.941. Okay, and so there's because they're made up differently, it gives them different masses. Here's what we get. If we have a mole of copper, we look at the periodic table. Sorry, a mole of oxygen. We look at the periodic table and we can get this, 15.994. Okay, but how many atoms is that? 6.02 times 10 to the 23rd atoms. Okay, if we have a mole of copper, it has a different, we look at the periodic table, it has a different mass. A mole of copper is 63.546 grams. But notice it has the same number of atoms. Okay, so you'll see that with the periodic table, okay, all the masses are different. Okay, but all the numbers of atoms are the same. Okay, and that's what we're trying to get across. The periodic table shows how the atoms are different, but we already know that these are the same. Okay, and so this number here, 6.02 times 10 to the 23rd, is called Avogadro's number. Okay, Avogadro is the guy who came up with that number, and unfortunately, he didn't get a lot of credit for it. Okay? So again, the masses are different, the number of atoms are the same. So other things that the mole equals, okay? If it's a gas, any gas, doesn't matter what kind of gas, okay? 1 mole of gas, so again, 6.02 times 10 to the 23rd molecules of gas will take up 22.4 liters, okay? Equals 22.4 liters. We're going to come back to this a little bit later, but that works for any gas, and this is why those gas laws, okay, work, okay? They work because of this constant, okay? And then where we're going to go in the next video is that a molecule, 1 mole of it is equal to its molar mass. So the periodic table reports the mass of the individual elements, gives the molar mass of the element. But if we have something like H2O, well, that's not found on the periodic table, but the parts are. So we have 2 H's and 1 O, and we know how much the H's weigh. And so we can add up all of this to come up with what the molar mass of the compound is. Okay, so a mole is also 1 mole equals the molar mass of something. So we'll stop here. So this gives you an idea of what a mole is. We will pick it up there with calculating molar mass. Okay, have a great day, everybody.